Thanks. Right, so I think everyone's probably met me. I don't know if I've met you before.
No, I don't think.
Okay, I'm the research software engineer, the only one at Aberystwyth University working on the Supercomputing Wales project. And I saw Ed put out a call for talks, and I tried to think of something that would apply generally to lots of research software engineers. And a few years ago, I had some experience with Jenkins and continuous integration and thought that was a good topic. I'm just interested to know, though, how many of you have actually used Jenkins or some other continuous integration platform before? Okay, good. So this is all new to you, mostly. Right, so what I want to talk about is, firstly, what is it, what is both Jenkins and continuous integration as an idea as a whole, how I used it in my previous job and where it was and wasn't a good idea, and how well it actually fits in with research software development. This is very much an idea that's really come from industry. It's not, from what I've seen, been very widely adopted in academia yet. And maybe it is and isn't appropriate depending on the size of your project, and I'll just have some thoughts on that at the end. So Wikipedia defines continuous integration as the practice in software engineering of merging all developer working copies with a shared mainline several times a day. And this kind of grew out of the idea of extreme programming and agile methodologies that came around in the early 2000s, where you really tried to cut down on the amount of manual processes that are around your software and try to get software to quite a lean process that can be done quickly and efficiently. And it's often complemented with things like version control, as in Git or Subversion or Mercurial, with unit testing frameworks that will automatically go and test individual components of your code, automatic reporting, and software metrics that go and measure things about the code. So it could be measures of code quality, of how many errors you've got, of even just the number of lines of code, and these will often get presented back as a single report. So this can be quite nice for management to look at and go, yes, your code looks really good today, or no, your code's failing, but also for developers to see what else is going on, but to have also this continuous process of the code being automatically tested and exercised, and that if a developer commits something into the version control that is broken, they know about it very quickly, and they know about it before it hits the end user. And also in this, you've automated a lot of the processes that you would have had to do manually before. So hopefully, if you do this right, it's less work for you, not more work for you, and that what you're being told is useful information that actually helps you develop more efficient, better software and waste less time chasing silly little bugs. Jenkins is a platform for doing CI. It's open source, it's written in Java, and originally had a very Java-heavy focus to everything. It was really intended for Java developers, but these days has millions of plugins for just about every development environment you can think of. It's normally self-hosted, so you run it on your own computer or on a server. There are a few cloud-hosted options out there if you want someone else to go and host it for you. And you just run it from a Java web archive file. Now, if this works, I have a copy on here. Is that readable-ish to everyone? Yeah. So basically all I'm doing is Java minus jar and the Jenkins WAR, which means a web archive file, and that will launch the Jenkins process, which should password in. Launch a web server running on port 8080 on my local machine. At work I have a server with this on as well. It takes 30 seconds to start. So this is the home screen. So each of these are different projects that I've put into Jenkins. The cloud kind of indicates what the recent trend has been with that project. So if it's raining, it's not been doing too well, there's failed some things. If it's got a lightning bolt, it's really, really not doing well. The sort of cloud means it's had a couple of successes or only a couple of small failures, and if you have a sun out, then it's doing fine and everything's okay. And these are just two example projects I put in here which have had quite a few failures as I tried to get them to work in this environment, and they're just about up and running. I think the one in red at the bottom still got an error or two. So in my setup in my previous job, I was the data manager of a place called the National Plant Phenomics Centre in Aberystwyth. This is a giant automated greenhouse that runs around plants on these conveyor belts, and it will take images of them automatically, it will weigh them automatically and water them. There's often multiple experiments in there at any one time, and we have a web-based system for managing those experiments, and also managing the applications that people put in to request experiments to be run, including an approvals process and letting the users get back at their own data once it's finished. This system was inherited from my predecessor, who was certainly not a software engineer, and it was a bit of a mess. There was absolutely no version control, no automated testing. It was only deployed in a live server, that was the only copy. And I was getting a lot of requests when I first started, can you fix this small bug in it? And I was fixing that small bug, or I thought I was, and then I was breaking other things inadvertently. And I realised that what I needed was something that would actually test the system and let me know that I'd made these small errors before I deployed them to users, and then had users moaning at me that things were broken when they shouldn't have been. This system's written in PHP. It didn't use any fancy PHP frameworks, and there was enough code there that was worth not throwing away that I didn't want to change it. Maybe my successor will still change that. There's a few thousand lines of code in total, about 50 pages. There were roughly 20 active users. And it was semi-critical to the functioning of the place. If this went down, they actually couldn't start an experiment because this system produced a list of barcodes that had to be scanned by the actual machinery that ran the system. If that wasn't available, they couldn't start the experiment up because they needed hundreds of barcodes printed out from that system. Oops. So in my setup, I put everything into Git, and I used a GitLab server that I ran myself, but you can do the same similar with GitHub if you want to. And whenever I pushed to Git, Git would generate a web request to Jenkins, which is what it calls a hook, that would say, there's been a change. And Jenkins would pick that up and then automatically start the build process for my software. And I then had it run a program called Thing. If any of you have done development in Java, there's a very similar thing called Ant, which is an XML-based thing for building software. Or if you come from the C++ world, you may be familiar with Make. I'm sure most other languages have an equivalent tool, especially if they're compiled. But I had a Thing script that would run some unit tests and unit test most of the code. It would run something called PHP mess detector that looked for sort of bad practices in PHP and tried to highlight where you've done things that you shouldn't be doing. A copy-paste detector that looked for duplicate code. A lot of the code I inherited had complete duplication of things in it with one variable name difference to do two subtly different things, and I was trying to eliminate that. PHP Code Sniffer is a static analysis tool that looks for sort of common bad practice and tries to suggest other ways of doing it. And then finally, PHP Doc generates automatic documentation from each of the classes. Now, because this is web-based, what that doesn't test is the actual user interaction of pressing buttons on web pages. So the unit tests are fine for testing low-level interacting with the database type functionality, but they don't test anything in the UI level. We had another program called Bhat, and Bhat basically is a highly modified web browser that pretends to click on things, and you then have some simple scripts that say, when I click on this button, I expect to see the following text on the responding page. So you can kind of run through every single user action that might happen in the system and test it. And we found Bhat was a little bit limiting when we started having some JavaScript in this. We had another platform called Selenium with a very similar idea with an automated version of a web browser. Once all this is done, and this takes about 5 minutes to run on our current setup, Jenkins would bring back a report on the website showing you the results of all these things. It would also email a report telling you whether it succeeded or failed. I think if you get multiple successes in a row, it stops emailing you, and then only when you fail does it. And we also had it report a message on Matamos, which is an open source Slack clone, telling us that the build had succeeded or failed. So you can find out from there what's going on. So this is just an example of some output. This is a unit test which has failed, and it's showing you the output here from the unit test. And if you look very carefully, you should see that some text doesn't quite equal. And basically it's checking the text output would be the same on both. There's a graph that it produces there showing a test trend result of how the tests have gone over time. Where it's gone red here is the failures. The reason these have dropped down and then back up again is not because we eliminated half our tests, but when Bhat runs, it also produces a unit test file, and that looks very similar to the PHP unit test file. But if the PHP unit fails, Bhat never runs, so there's only half the number of tests being done. And then there's various options here that you can click on that will tell you the reports from each of those other processes that I mentioned. The check style thing is very pedantic about the code style, and something we took quite a while to do was get a code auto-formatter that would put the code in the same format as the check style wanted it, so that at least the code we had in there should have conformed. And it's very pedantic about how many spaces you have after commas and things like that, but it is quite a nice way of enforcing a coding style, because as soon as you submit something that doesn't quite match what you're supposed to do, it complains at you, and you suddenly get these red bars coming up, and you really want to then go and fix it and get back to that nice sunshine and the blue buttons showing that everything's built successfully. So it's quite a good way of enforcing you to write code that meets a certain style. I imagine when you bring in multiple developers and you want them all to produce code that looks the same, this is an excellent way of doing that. And this is an example there. If you click down, you can actually have it highlight the line where the errors occurred. And here, I think we forgot to put some spaces in those parameters with a new line that being generated. BHAT as well generates its own reports. And this kind of shows each scenario. So it's got kind of a English-like way of showing things. So it says, given I am on register PHP, and I fill in the name box with test and press submit, then I should see, please fill in an email address, because they didn't fill in an email address. And there's hundreds of these scenarios that test all of this. And I had a student work for me over a summer who spent half his time just writing these tests, which I'm quite amazed he didn't get bored doing, but he seemed to quite enjoy that. There's also the PHP doc there showing the documentation from all of the classes we produced. So this does complain at you quite a lot. So if your unit test fails, if your code doesn't meet the style guidelines, if you do any of the bad practice things in the mess detector or the code check style, if you duplicate code, if your BHAT or Selenium tests fail, you get an email telling you that you shouldn't have done this. As I said, it can be quite pedantic, but it does make you do things right, if you've got it set up at least in a consistent way. So fun ways of doing this is some people have got these little things that they call build bunnies, and these kind of show the mood of the current build. And you can integrate these with Jenkins.
I am connected to Team Foundation Server.
This is actually using the called Team Foundation Server, but very same principle. If you want to be slightly more aggressive, there is this mode where you attach a USB missile launcher. And of course it knows which developer made the commit, so it can go and shoot the right developer. We never got as far as implementing either of those, unfortunately. Just a fast, simple example is I had another project which was to build a touchscreen interface on a Raspberry Pi and single board computer for this tiny little thermal imaging camera. And this turned into about a 300-line Python script, mostly dealing with the touchscreen stuff. And that doesn't really lend itself well to automated testing because you need the real hardware there to test most of the code. But what I did find is I wanted to go and publish this on GitHub, and I wanted to make sure that I was at least compliant with the Pepe code style standard that Python has. So I just set up a really, really simple Jenkins job that would take the code from Git and just run Pepe and produce a report telling me if I was or wasn't in compliance with that coding standard. So you don't have to have these giant, massively scripted builds. It can be really simple checks that go on. Just a few words of warning that Jenkins has, over the past, and I think there was one in the last month, had a few security issues. Don't leave it exposed to the internet. You're bound to get a hacker coming in. It has quite a lot of features that let it run arbitrary commands on your system because you need that for building things. So it's a great way of introducing a security vulnerability to your machine. So I would very much suggest that you just bind it to localhost or put a firewall in. It also lets you have its own login system and require usernames and passwords, but this isn't the default, so make sure you switch that on if you are going to go and install it, and then at least you don't have random hackers trying to log into your Jenkins server. And there are quite a few other programs that do similar things. A very popular one is Travis CI, which GitHub tend to push quite heavily, but this is entirely based around a YAML config file. There is no web front end to help you configure things, and it's a hosted service that runs inside Travis, so you don't have as much control over the environment, and getting some more complex jobs to run can be a bit of a pain. But because GitHub's built quite heavily around it, there is quite a lot of support out there for it. Circle CI is kind of a similar idea, but they've used Docker containers to run everything in, and again, it's all a cloud-hosted service that does it all for you. Where you've got a kind of halfway house is GitLab has its own built-in CI system now. Again, it's based on YAML scripts, but you can either use their hosted service on gitlab.com or you can host it yourself if you run your own GitLab server. The real question is this appropriate for a research software engineering environment? And I feel as research software engineers, we should be producing code that is of professional quality. And if you haven't read it before, there's a very good essay out there called The Craftsperson and the Scholar. on the Software Sustainability Institute's web pages, and there's slightly more detail in this talk I found on there. And it talks about the kind of software that researchers produce, and they have PhD-ware of things written in a PhD that just make one graph and maybe just produce one figure to put in the PhD, and they never get run again. They're totally unmaintainable, completely unreusable, and I'm certainly guilty of doing this. I'm sure most of you probably are as well. And you also got a slight step up from that is labware, where you get one genius in a lab who writes this amazing piece of software that other people maybe go and use, but they don't understand it at all. It's not written for readability. No one else can make any additions to it because no one else understands it. And we should be producing software that's better than this, that is accessible to other people, that other people can build upon, that they can reuse. And if you do that with software, you're going to get more reuse, you're going to get more citations of your software, and that hopefully ticks a load of boxes for you getting a future job and more funding. So I've said most of that it should be professional, it should be well documented, and in industry, continuous integration practices are pretty much standard practice in certainly most companies that are doing it right. But that doesn't seem to be the case from my experience, at least in research. That's relatively rare, and the fact that I think two of you put your hands up saying you'd heard of this before kind of illustrates that point. And so maybe this is something we should be using more of and trying to improve the quality of our software a bit. There is a case against it, that it does take time and effort to get this stuff configured, and you need to obviously pay that back in future. And it works best when you're incrementally developing software, I find. If you're making radical changes to your software, you're not going to have unit tests for everything. You're going to break your build massively, and you're going to look at it and see you've got 20,000 errors, and just think, no, I'm never going to fix all those, and you stop using it. And after I'd done a load of work with this software, I had another student come and work for me who was given the task of radically overhauling it, and he basically completely broke everything because he didn't keep up to date with getting unit tests and everything written. And he didn't take a very incremental approach. He tried to change everything at once, and it all kind of fell apart a bit. It also really lends itself to having multiple developers. It's when you want to enforce things on multiple developers. But even on your own, I think it can still pay off. It still helps with small projects. As I showed with the touchscreen example, you can just do really simple checks, like just checking that you comply with a style guideline. But then if you're using an IDE, you may have other plugins that do that, and that might be an easier way for some people to do it. What I liked about doing it that way is, regardless of what editor I write it in, Jenkins will always pick it up, providing it goes through my Git server. And that's it. I've got a little demo of it if anyone wants to see it running. So I've got two jobs here. One is a little calculator I wrote to do a seminar on Jenkins a few years ago. So here you can see I've got this test trend result as well, so there's a simple JUnit test. Over here there's a history of all the builds, so it shows you the time each build was done and whether it's successful or not. So the red means failed, the blue means success. If we want to see why it went wrong, we can click on one of these and see that there were no test failures in this case. There's the output from the GitHub commit comment. I can also go to console output and see everything that came through the console. So there it is checking out Git. It's running Ant, which is going to invoke the Java compiler and the unit test. It says build successful, but then after that there's an error step. It's scanning for compiler warnings, and it turned out I didn't turn on the output for the warnings, so it couldn't pick up the file for them. So for the latest build, you have the workspace, which will show you all the files that went into that particular build, and these are stored somewhere inside Jenkins, and you don't generally access them anywhere outside of it. But if you want access to any of the report files, they're in there, or any of the output files, or to see exactly which version of the code it was building against, then log files will also go into that directory, and it will happily zip them up for you and give them all back to you in a single zip file if you really want to get back that workspace. I'll just show you configuring it as well. When you create the project, it will ask you a load of questions about what to do with it and where it's going to get it from. So first is source code management. So this is where am I getting the code from. So I've chosen Git, and I've put in the URL repository to my own GitHub there. The next bit is build triggers. If you want it to build automatically, you can show how it's going to build. So I mentioned before I had that automatic web triggering. You can also have it poll periodically and say check every 15 minutes if there's an update and just automatically compile when that happens. Or you can actually have one project dependent on another. Then there's some things about the build environment if you want to change in the environment settings. And then finally there's the actual build step. So in this case I'm executing a shell and then these are the commands I'm running up the shell. So I had to set a class path for Java and then I'm just running AND with those targets and that's causing the project to compile. And then finally there's the post-build actions, which is what you do to report the results afterwards. So here the only one I've got is to report the JUnit test result, which is just taking that file from test reports and then presenting that on the Jenkins homepage, which is what makes that graph up at the start. But obviously these get a lot more complicated when you've got bigger projects. And that's pretty much it, really. Any questions about that?